Hello, my name is Ken Spall. I'm an architect in Las Vegas, Nevada, and this is part 2 of the series on the solar installation I did on my house in December of 2016 was when it was completed. If you saw the first video, you'll know where we're going. A lot of the videos that I saw online that were talking about solar install, you didn't really know where they were going until you got to the end. So I showed you the end result first. The rest of it is the journey, and so we'll begin with on-grid solar system selection. So first of all, you should know that my house is in a fairly urban area where having the power go off is fairly rare. There might be some consideration for what happens when there's a catastrophe and the power utility goes down for days. But a typical power outage in my neighborhood happens about once every 2 years, and then it might last anywhere from 5 minutes to 2 hours depending on who ran into a power pole or what transformer got overheated and blew up. But we're not looking at long periods of time of not having electricity. There's also really no provision locally for operating off the grid. That may be possible, but it doesn't seem like a logical way to go, given that we're in a fairly urban area. And hopefully the time will come when the systems become efficient enough to where that becomes economic in urban areas, but right now it's not, by my opinion. I start out looking at sizing the system to make it give a good payback. Some on-grid considerations would be that electricity is not sold like items that you're used to buying, like bottled water. So if bottled water costs 50 cents for a bottle, then you might get 3 for $1. But electricity, the way they price it, if you relate it to bottled water, would be as though the first bottle costs 50 cents, and the second bottle cost $1, and the third bottle cost $2. So your worst case scenario in the summertime in Las Vegas, where I live, you might be buying 3 bottles an hour, and so the low-hanging fruit for payback is going to be to do away with that third bottle that costs $2, and then the next most obvious payback is the second bottle, which costs $1, and then trying to get a payback on that 50-cent bottle of water is going to be pretty hard to do. When you add the whole system together, first, second, third bottle of water system, then the whole thing might give you a payback. But as far as looking at it in the 3 pieces, the peak rate charges for the peak of summer are going to be where your quickest payback will be. And since nobody ever knows whether they're going to be in their house for 3 years or until they die, most people are interested in a 5-year payback. In Las Vegas, and given the size of my house and what our bills are and all that, we thought that a 5-year payback would be good to aim at, although that wasn't the real consideration driving it for our house, and I'll talk a little bit more about that later on. But some of you may be interested in, for green building purposes or helping the earth, or just for your own investment that you'll be sure to get a payback on, that you fulfill 100% of your electric needs, which is a good goal as long as you don't look at it as an economic goal. You're just thinking that we'd like to do that for whatever reason, and it should pencil, but it may not be the best investment. That's doable. If you're going to do that, then you're going to need both solar panels and batteries, because most people will have a need for electricity in the middle of the night when the solar panels are not producing any electricity, and batteries are the only viable way that works in a solar system. Of course, there are other things you can do, water generation, wind generation, and so on, but we're talking about solar systems here. So in solar systems, the solution is going to be batteries. So I first ran some initial numbers looking at how many watts of energy I had used and when, different times of day, and batteries, and lots of options. And what I learned was that the orientation of my house is not adequate for trying to fulfill all the electric needs of the house, whether you're willing to buy batteries or not. I have an area of flat roof on the house, which is not oriented ideally for anything. That area of flat roof is not particularly well constructed and would have to be repaired and have the roof replaced on it, so that's no good for solar. And then I have two large areas of roof that are facing east and west, which would only get you either morning or afternoon sun. And again, it's hard to get that to pencil because you're just not adequately oriented to get the ideal optimized use of the panels. And then we had one area of roof directly over our two-car garage, which is also where our main electric panel is at. And that area of roof is good for in the range of 5,000 to 75 or 5K to 7.5K system. And so that size system on my house, which is 4,200 square feet and has a peak summer bill of, grab your throat for this one folks, $650 a month plus, and that would be able to save us that third bottle of water for sure. Now it's a little more complicated than that because we have an electric vehicle, and so we get the electric vehicle rate. So some of the things we run in the late evening at the cheap rate, like our pool and our jacuzzi, and therefore trying to switch those over to solar during the daytime to take advantage of the electricity from the solar panels doesn't exactly work in July and August, because then you're not producing enough electricity to run that and the house. So it depends on the day. If you're like us, we're frequently at work Monday through Friday, and we're frequently home on the weekends. So certainly on the weekends we could turn the pool and the jacuzzi pump to the late evening hours to get the minimum rate of electricity, which starts around 10 o'clock and ends in the wee hours of the morning, and try to run the house itself off of solar. Looking at that, the way most manufacturers' systems work, and the type of air conditioning system that we have, we would need three-phase power. And again, running the numbers on that and the number of panels I have on the roof, didn't make any sense to try to get that second bottle of water and first bottle of water. So we opted for a single-phase inverter. Looking at the batteries, if we did decide to put all the panels on the roof that we needed to generate a 10K system, and then capture some of the electricity during the daytime to reuse during the nighttime, coming close to fully supplying our electric needs using battery and at night, and right off the solar panel inverter in the daytime, or inverters in the daytime. We'd need right at about $24,000 worth of batteries. And so those wouldn't be just the traditional cheap batteries that are like car batteries, but they'd be lithium batteries or some of the other high-tech batteries. But $24,000 for batteries, the numbers didn't add up for me. So ultimately what it came down to is that a few years back, when solar panels were 250 watts per panel, the roof area over the garage, which is oriented slightly to the west of south, it's still not ideally oriented, and it's not the right slope. It's 4 and 12, where you'd want something more like 7 and 12 for ideal solar angle. Then that didn't pencil because it wasn't generating enough power to make it even worth installing a system at all. But in this year, Nevada power and some of the other political factors in Nevada have acted detrimentally to the solar industry, and prices went down. So technology's improved at the same time, and ran the numbers early summer, and 320 watt panels, the panels that'll theoretically generate 320 watts in a perfect world on a perfect day. 22 of them would fit on my roof in my garage, and that would make it enough to be a worthwhile system to go to the trouble of buying the inverter and installing the whole thing, and the hassles with the power company and getting the plans drawn and doing the building department process and all that. So even though I'm an architect and I did draw my own plans, so to speak, there's still a cost there. And if you can't get up to a certain minimum amount of electricity, which is somewhere in the range of a 5K system, to me it didn't seem like it was worth it. Your time may be less valuable to you than my time is valuable to me, but as the solar panels improve in efficiency and the area that it takes to get the same amount of electricity, the roof area it takes to get the same amount of electricity, the numbers look better and better. And so I looked at all that and a few other factors that I'll talk more about, and it made sense to me to go for a system that would be generating a little over 5K. And from that, I did quite a bit of investigation into batteries, because I was in dumbfounded disbelief that $24,000 was going to be appropriate number for batteries to offset the use of the energy from when it comes in. So offsetting just means that if I'm gone to work during the day, maybe one person is in the house who actually likes to keep the house pretty warm. In the evening, everybody comes home from work, we crank up the AC, we turn on the oven, and that, after the sun has gone down, is when we really need the power. So you pump all the power into the batteries in the daytime, and you suck all the power out of the batteries between when you get home from work at whatever it is, 5 or 6 o'clock, and when the rates go down to the minimum rate, which could be at 10 o'clock, 11 o'clock, depending on where you live besides Nevada. So that little range between 5 and 10 p.m. would be what you would try to fill with batteries to get that second bottle of water. When we looked at it, it didn't really pencil, and it looked like it should, and the price of batteries is falling every year. So it was hard for me to say that I didn't ever want it. I looked at a lot of different systems. There's some really good manufacturers out there, some really tried and true stuff which runs dependably and is well rated online, and you've probably looked at videos from a lot of these other manufacturers. I called the Alt-E store online, among quite a few others that I talked to, and they recommended the SolarEdge system. And I began to examine the SolarEdge system and find out how it worked and what the upside and downside of it were. And those up and downsides are essentially that it is designed so that you can plug in batteries after the fact and utilize them. And reportedly it works with the Tesla wall battery system, even though Tesla's sold out for now. and it just is a straight plug-in. So after you got the whole thing installed, if you decided that you wanted to go ahead and install batteries later on, you wouldn't have to go in and rewire it or add some supplemental system to it, or bring a bigger level of complication to how the whole thing works. You could just do a straight install of batteries, plug it in, and change the programming a little bit, and boom, you're done. But looking at the amount of electricity that it generates now, and trying to vary when the pool pump runs, when the dishwasher runs, when other things that are on timers run, the jacuzzi runs, it looks like we can get a real good payback out of the 5K system that we have without having to fiddle around with batteries. Another thing that you can say with the analogy of bottles and bottles of water and electricity is that if one bottle of water sells for 50 cents from them to me, and 2 bottles at the same time sell for the second bottle $1, and the third bottle is $2, if they buy a bottle of water from me, it's bought for the equivalent of 10 cents. It's like they almost give you nothing for the electricity that they buy. So optimally, if you're planning on banking the electricity by collecting it from the sun and pumping it into the public utility system in the daylight and then taking it back out at night, which allows them to reduce their peak load, it seems like it would be worth more than the 50 cents a bottle for them to buy it, but that's not the way politics works, and so it's really not economic. Other than just throwing away the electricity, I don't know what you would do with it. You can't sell it to the neighbors or anything, so obviously whatever electricity is left over, you're going to take the 10 cents a bottle for the bottled water analogy, but makes better sense to have your pool pump come on, or have your dishwasher, run your dishwasher when you leave for work or whatever. So that's what we're doing, and I think it's interesting to try to run a bunch of comparative numbers on all this to make a decision. If you have a big roof area and you can do lots and lots, but because we're talking about a extremely complicated spreadsheet that NV Energy will allow you to download that shows when you bought power and what you paid for it on a day-by-day basis, trying to turn that into some mathematics to try to convince yourself of whatever didn't make any logical sense to me. It was a lot of brain damage to convince myself that if I had more roof area than I do, that I could do something else. But when you go with a moderately sized system that you know isn't fulfilling your full capacity, you have a much greater chance of getting a short payback. So the 5-year payback is what we were going for, and so what that means is if electricity doesn't go up in price at all, then in 10 years I'll have twice my money back, and so on. So I actually plan to be in this house indefinitely, and so hopefully I'll be there 10 years and get double my money back, and that's a darn good investment. After we have a year to play around with turning the other items off and on during the non-peak summer conditions, and seeing how much of the electricity of peak summer the system covers and what we save there, then we can compare year over year and see how many gross dollars we actually saved. And then we can look at the analysis of energy sold back to the grid that we sold back to them for 10 cents a bottle. We could decide that it makes sense to buy batteries, it makes sense to put some west-facing panels on there, east-facing panels, you name it. We did get an inverter that's quite a bit oversized for the number of panels that we have on there, because the incremental cost increase over the smaller right-sized inverter just didn't make any sense to buy the smaller one. You still need the same electrician, you still need the same wiring, you still need all the other same stuff, and you have to go through the building department and and then you might end up wishing you could add on, and if you've right-sized the inverter, then you have to go and add a second inverter or go through a bunch of other redoing process. So we didn't want the redoing, we wanted it so that if we add that, then we can just take the drawings the building department already approved, draw 3 more, 5 more, 10 more, whatever it is, solar panels onto the same drawing and cloud them as this is what's being added to the system, get a building permit and slap them on there and be done. The way these systems work that we selected are all snap-together systems, so it could be done by a do-it-yourselfer. And this is another reason why I selected the SolarEdge system. Most inverter systems don't have optimizers on them. And what optimizers do is 2 things. One is if you have a shadow going across your solar panel area, which I do, I have a palm tree which casts a relatively small shadow, but it moves across the field throughout the day, then those optimizers enable each panel to optimize itself individually. If you buy a system that only has one inverter and no optimizers, then it optimizes the field of panels together, which means having a shadow on one panel is going to have a detrimental effect on the electricity you get from all the others. The other thing that the inverter system does is when it doesn't see the grid, the inverters produce 1 watt per inverter. So even though your panel will generate 320 watts, it's only going to produce 1 watt. So say you're a do-it-yourselfer, which I am, and say you can't resist tinkering around with things, which I can't. Something's not quite right, you want to fiddle around with it, you go over to the inverter, you flip the inverter off. Even in the peak of the summer when lots of electricity would be coming out, all the inverters drop to 1 watt per inverter. You can go up there, switch snap connectors around, move this, move that, lift up a panel, shoo out the birds that are living underneath it, whatever's going on, and not worry about zodding yourself with the entire capacity of the electric array. Even getting hit with the electricity out of one 320 watt panel is going to be a nasty experience. But with the inverter system, you don't have to worry about that. So those 2 features attracted me to it, and what I was saying before about possibly doing east and west panels, when we look at how much is actually produced through this slightly west of south oriented system throughout the day and how much we're using throughout the day, if we decide to add some other panels on it at odd times, we can bring that inverter all the way up to its maximum capacity throughout the day. So we could have some that are straight facing up. I don't know why you'd want to do that, but you could. On the flat roof, we could have some, actually the flat roof faces slightly north of straight up. But you could do that. You could have others facing west and others facing east and put them all on the same array strings with the south-facing panels that we have now, and as long as you didn't exceed the overall inverter capacity, then it would all work together, and the optimizers will individually optimize the power production of the panels, and you could get a lot more power out of the system than what I'm getting now, and more throughout the day than you would with a system that's just facing straight south. because obviously if you have a roof that's facing east, its inverters will come on whatever the minimum output from the panel takes to turn the I didn't mean inverters, turn the optimizers on, and then the inverter will come on as a result of those east-facing panels much earlier in the day. And then the same thing for west-facing panels. So say that you're early to work, you're out of the house at 4 o'clock in the morning, but you come home at 2 o'clock in the afternoon, then you can put some west-facing panels on your house, and you're going to get energy late in the day that you wouldn't be getting from south-facing panels, or wouldn't be getting as much from adding more south-facing panels. So having the individual optimizers on the system helps and makes a lot of sense for trying to dial it in depending on what your personal schedule is, or whoever you might sell the house to, or what have you. Makes it safer for you to tinker around with, and then you don't have to chop down your favorite tree in the front yard, which I frankly may do anyway when we see the numbers on it, but for now we decided to keep the tree. So with that, I'll tell you that we have 2 strings of 11 each of 72 cell 320 watt panels in the system. And I got a screaming good deal on the panels, and this is what pushed me to do it now instead of putting it off to another year. By the time you watch this video, there will probably be good deals available on 350 watt panels, 400 watt panels, you name it. In my opinion, it's not really worth it to pay a super premium for the highest output wattage panels that are newest on the market. However, one size less, whatever last year's latest greatest panels are, is probably the sweet spot where you might be able to get a deal instead of paying an extreme premium. And unless it's just a matter of you need to get up to that minimum to make it worth it for the area of roof you have, then going for last year is probably the way to go, which is what I did. There are quite a few variations up into 345 watt and different size panels that produce more power than the 320s that I have, but I didn't want to pay the premium for it, so went for the good deal, shopping on eBay and all that, and actually bought 1 more panel than I needed just in case, or 2 more panels than I needed just in case something went wrong. And I was real happy I did that, because the 24 panels that were shipped, 1 of them arrived busted, and the seller gave me credit back for the one that busted, and now I've got 1 that is just stored away as a backup in case something happens to any of the others. And I consider that to be good insurance, since they're all on the front of the house. They all match each other. Sooner or later, if something happens to anything on anybody's house, so having a spare is a good idea. With all that said, then once I had the solar panels, I knew that I had the area of the roof that it would work in. I decided to go with the SolarEdge system. I talked to a fellow named Bramley at the Alt-E store. Their prices aren't the cheapest, and I'm experienced enough to know when I don't really know exactly what I want, and I haven't done this before, it's probably worth paying a small premium. And I want to say it was a small premium, not a big premium, to go through Alt-E store and have Bramley look at my drawings and tell me what I needed and give me some advice and kind of steer me in the right direction. And he was very patient, and I thought it was well worth the investment to go through them. I'm sure there are plenty of other good suppliers. My experience with local suppliers and installers when the boom for building solar was that it was nearly impossible to get a good deal. And I do know a couple of people who went out and bought their own equipment and then got a local installer to install it during the solar boom. But most people got almost robbed outright. And then nowadays, buying your own equipment and having somebody else install it is probably the best way to go in terms of getting a deal, if you're willing to put in the time and effort to make sure that you're getting the right thing, ask the questions. Again, time is money, so if you're a brain surgeon, just pay somebody to do the whole thing for you and pay the extra. But if you're just a regular guy and you have a little weekend time and you can do your own investigation and all that, then go ahead and buy your materials. And after you have all your materials in front of you, find an electrician, bring him over, show him what it is you're going to do, talk to him about how long it's going to take in a reasonable way, and you're probably going to get a much more affordable deal. I certainly did. I actually thought I was going to install the system myself when I first started, but ultimately I used an electrician that's experienced in solar installs, and that's because I felt like I was getting a fair deal. And again, my first rodeo installing my own solar system, although I've had quite a bit of experience in solar design, never tried to install one. And even though it looks like it'll work as a do-it-yourself deal, I thought for the additional money I paid the electrician, it gave me a much better comfort level, and it wasn't unaffordable. And in the end, I'm going to be living with something a long time, and so maybe it's the difference between working on your own car and hiring a mechanic. Yeah, you could probably do it. Yeah, you could probably figure it out, but do you really want to get stuck out on the road? So there's some things I did, and the electrical work per se was not one of them. But there is certainly plenty of other work for me to do, and so when you're a homeowner and you're doing a project like this, believe me, even if you think you're delegating the whole thing to somebody else, there's going to be plenty for you to do. So those are my thoughts on the on-grid solar system selection. I'm going to go into the details of the components and walk you through the whole install going forward in future videos. So thanks for listening. Ken Small, Architect, Las Vegas, Nevada, 702-873-1718. As an architect, I don't do just installs, but if you want to do a building, a house with solar on it, love to do the whole thing for you. Could probably recommend some people to help you with just the solar install if that's all you want. But not in the business of selling hardware, software. Have no business relationships with any of the people that we're talking about here, although I wouldn't mention their names if I didn't recommend them. But you know, your experience may vary, so hopefully they worked good for me and they'd work out good for you. But when you're doing it yourself, you know how that goes. Everything's at your own risk. So thanks for watching the video, and please click on like and share this, and then go to my website, www.smallstudioassociates.com, and like and share the website and the videos.